I'm Chen Kaiying Janice. I'm going to present question 1D for the mock examination 2. A financial analyst is interested in the percentage of revenue spent by computer software companies on research and development. A random sample of computer software companies is selected and the results are summarized in the following table. So this is the table given by the question. Question 1D requires us to construct a 99% confidence interval for the mean percentage of revenue spent by all computer software companies on research and development. So, based on the data given by the question, first of all, I've calculated the cost mark for each percentage of revenue and notate it as X. And I've also notated the number of computer companies as F. After that, I can calculate the summation of F, which is equals to 50, and the summation of Fx is equals to 418.1, while the summation of Fx squared is equals to 3643.99. To answer this question, we also have to calculate the mean, and the mean can be calculated by using these two information, and the mean is equals to 8.362. We also have to find out the standard deviation. And the deviation can be calculated by following this formula. After substituting the data we have calculated above into the formula, we can find out the standard deviation as 1.736979551. As the question states that it is a 99% confidence interval, the alpha will be equal to 0.01. And according to the central limit theorem, because the summation of F is equals to 50 and which is larger than 30, which is a large sample, and we have to calculate the confidence interval by using this formula. And the corresponding Z value according to the Z table, it will be equals to 2.576. And after that, we can calculate the confidence interval by substituting all the data into this formula. And the answer for question 1D will be equals to 7.7292% and 8.9948%.
So I'm gonna talk about question number 4, sub-question number A. The problem is about a sales manager who wants to compare the recent performance of his two salespersons. From the sales record, their daily sales were normally distributed with the same mean and standard deviations with 200 and 250. The amounts of sales of 10 days in the sales record will be selected randomly from each salesperson. And now for this questions, we're going to calculate the possibility that their mean daily sales will have a difference of at least 150. We have if the first salesperson was X1 and the second salesperson is X2, we have the mu for X1 equals to mu for X2, and the sigma for X1 is 200, sigma for X2 is 250, and the number of selections was N1 equals to N2 is for its 10, because it selects 10 days. So mu x bar 1 minus mu x bar 2 will be equal to mu x1 minus mu x2, which is equals to 0. And their form we apply with the replacement or from the infinity populations, which is to this this equation, which is a sigma x1 bar minus sigma x1 bar minus x1 bar 2 equals to the square root of n1 over sigma 1's square plus n2 over square sigma 2 square, and we plug in the number which would be approximately 101.2423, and 6 sigma bar x bar 1 minus x bar 2 is normal distribution with a mean 0 and a variance of 5 of 4106 square. So we can calculate the possibility of x bar 1 minus x bar 2 over more than 150 equals to x 400 square, 5 times of 410 square over 1 x1 minus x2 minus 0, larger than 5 times 401 square over 150 minus 0, which we can change it into normal distribution probability of z more than 1.48 equals, and then so the possibility will be 1 minus 0.9306, which the answer will lead us to 0.0694.
So here is a question 4b, and the question is, in evaluating the customer satisfaction level, a company would like to be 95% confident that the error estimating the population mean does not exceed 0.05. So the standard deviation is at 0.8, and we have to find out the sample size required. And we assume that the population level is normal, and it is a 95% confident interval, so therefore the alpha over 2 should be 0.025, and the x value will be 1.96. So as the error in estimating the population mean does not exceed 0.05, and we will have this, and by substitution and after calculate, we will have the n should be greater than or equal to 983 and 0.44. So therefore, the minimum sample size will be 984. Thank you. And here is the end of the
Hi everyone, I'm Ben. I'm going to talk about mock free question 4C. This is a question. In a random sample of 500 clerical employees from a large multinational company, 300 said they would like the company to adopt a flexible scheduling policy, which would permit employees to decide when and how much they would work. Construct a 90% confidence interval to estimate the population proportion of clerical employees favoring the flexible scheduling policy. Explain briefly how the confidence interval should be interpreted. First of all, let the P be the population proportion of clerical employees favoring the policy. The sample size is 500. P hat, which is the employees in the sample supporting the policy, is 300 over 500, which is 0.6. The Q hat, which is 1 minus P hat, is 200 over 500, which is 0.4. The question states that the confidence interval is 90%, which means that we can find the alpha is equal to 10, and in the diagram, the 5% of the blue area is the critical region, and we need to find the population proportion is whether the population proportion is in the critical region or not. By central limit theorem, and the sample size is larger or equal to 30, so the sample distribution is approximately normal. We can apply the sample proportion equation. According to the standardized normal distribution table, the standardized value of alpha is between 1.64 and 1.65. Thus, the standardized value of alpha is 1.645. We can substitute the numbers into the equation, and we can get the final answer, which is 0.5639 is smaller than P is smaller than 0.6360. And this is the final answer of this question.
Hello everybody, today I'm going to present a question from Mock 4. The question number is 4A. In the study of turnover rate of new employee after 1 year period, 150 new employees from various departments are selected randomly, and 29 of them are no longer employed after 1 year period. Construct 98% confidence interval for the turnover rate. As we are now asked to construct a confidence interval, and the question is using proportion, so this equation is applied in the calculation. First of all, we can let P as the turnover rate, and N is the sample size, which is 150. We can use this symbol to represent the sample proportion, and the value is 29 over 150. 1 minus the sample proportion equals to 1 minus 29 over 150 equals to 121 over 150. As we are now constructing a 98% confidence interval, we need to find out the probability of these two purple areas in the diagram, which is outside 98% confidence interval. And the sum of these two purple areas can be represented by alpha, and then we can find out alpha by using this equation, which is 1 minus alpha times 100% equals to 98%. Alpha equals to 2%. The standardized normal distribution table can only show the probability of either side of the diagram. So we have to divide alpha by 2, which is equals to 0.01. That means 1 purple area equals to 0.01. It is the probability of occurrence of the purple area. Then we can look up 0.01 in the standardized normal distribution to find out the set value. However, 0.01 cannot be found from the standardized normal distribution table, but we can find out the closest value, which is 0.0102, and the value is 2.32. Then we can plug in all the data we have into the formulas, so we can calculate the result, and the result is 0.1185 smaller than P smaller than 0.2681. Then the conclusion is the turnover rate with 98% confidence interval is between 0.1185 and 0.2681. This is the end of my presentation. Thank you for your listening.